This video is about graphing rational functions. So we'll start with our prototype here and our basic rational function. The most basic rational function is y equals 1 over x. And its graph is going to be very different from any of the graphs we've seen so far in the course, because as we know for the domain of this function, we can't plug in x equals 0. Now, if you take 1 over a positive number, you'll always get a positive result. So positive x values and positive y values will go together here. And if you plug in a negative value for x, you'll get a negative value for y. So both these branches together make up the graph of y equals 1 over x. Please take a moment now and write it in your graph prototype sheet at the very back of your notes. Now, if we take a look at this graph here, we see that x equals 0, the y-axis, is what we call a vertical asymptote. It's a vertical line. Let me just highlight it here. It's a vertical line that the graph goes off the top of the page to avoid, or goes off the bottom of the page to avoid. That's a vertical asymptote. And here it would be x equals 0, pardon me. On the other hand, if we look at what happens to our graph for very, very large positive x values, so way out here, we see that our graph is getting closer and closer to the horizontal line y equals 0. And same thing is happening out to the left here. Okay? As our graph has very large but negative x values, the y values are becoming increasingly closer to 0. So that means that we've got a horizontal asymptote here, and its equation is y equals 0. Okay? How can I tell the difference between them? You saw I mixed them up earlier. The way to remember which one is which is if we look at that horizontal line, and I think of all the points on it, they all have one thing in common. They all have a y-coordinate of 0. So it makes sense to call the equation of that line y equals 0. Whereas for my yellow vertical asymptote, all the points on that line have x-coordinates that are 0. So its equation is x equals 0. Another way to think of your horizontal asymptote is to think about what values, what y values are approached when x gets very large as it approaches infinity, or when it gets large but negative as x approaches negative infinity. If they all calm down to a certain value, let's call it a, then we'd say y equals a is a horizontal asymptote. And as we said for a vertical asymptote, it's a vertical line that the graph goes off the top or the bottom of the page to avoid. So it would be a vertical line so that the y-coordinates will be getting arbitrarily large, or and positive, or arbitrarily large and negative as x gets closer and closer to that particular value. Now if we look back at our graph, okay, we already discussed just briefly the domain. We see that you can have any x value except 0, and also we notice that our graph never touches the x-axis. You can have any y value except 0 as well. So we can record all that information very easily just by knowing our graph prototype. So the domain is all real numbers except 0, and the range is the same thing. Now, for the x-intercepts, well, since it never crosses the x-axis, there are none. And the y-intercepts, well, I guess we can only have one ever. And it turns out, again, since it doesn't cross the y-axis, we've got none. Okay? Now we'll take that basic prototype and apply some graph transformations. And we'll pay particular attention to what's happening to the asymptotes. All our stretches, reflections, shifts are going to have an effect on those asymptotes. So we want to pay particular attention to that. So let's say we've got this graph here. Now I think about the heart of my function. My prototype will tell me where that is. So let's start off our recipe. So we'll start with y equals 1 over x. This is a rational function. We know that because the place that x appears is in a denominator. And where the x is in my prototype tells me where the heart of the function is. So the heart of this function is going to be that denominator right there. So based on everything we have, we're able to say what all the transformations are. By the way, you probably want to convince yourself that having 6 over x plus 1 is the same as having 6 times 1 over x plus 1. So that means that multiplier of 6 will have an effect of creating a vertical stretch on our graph. So that'll be our second step. Stretch vertically by a factor of 6. And then we've got some shifts. We're going to go 4 units up and 1 unit to the left. Now that's going to move our asymptotes, so we'll pay very close attention at that stage. Alright, well we've got our recipe, so let's draw our graph. Things are going to get a little bit messy here. Have a fair bit of overlapping. Now I know that a y value of 4 is going to become interesting later on, as will an x value of -1, so I'll put that on my scaling right away. We'll draw in the prototype. So there's y equals 1 over x. And now that graph, the blue one, I'm going to stretch it by a factor of 6 vertically. So all those y values are going to get multiplied by 6. Okay, so this piece up here is going to become stretched away from the x-axis, and this piece down here is going to get stretched away from the x-axis. So there's y equals 6 times 1 over x. And now the last thing we need to do is shift our graph 4 units up and 1 unit to the left. Now for the green graph, our vertical asymptote is still on the y-axis. Our horizontal asymptote is still on the x-axis. But all of a sudden, when I shift the graph 4 units up, that horizontal asymptote is going to shift 4 units up as well. So I draw my asymptotes with a dashed line. And when I move my graph 1 unit to the left, that vertical asymptote that's under the y-axis will all of a sudden shift 1 unit left as well. And it'll be there. So I've kind of got a new target or a new center for my final graph. Okay? So we're going to have something, we're shifting the green graph over 1 unit and up 4. So there's y equals 6 times 1 over x plus 1 plus 4. All right. Now, let's just briefly comment on those asymptotes. The final asymptotes of the red graph, so we'll call this a vertical asymptote, VA. Now, we can see the vertical asymptote right here. Its equation would be x equals -1. The horizontal asymptote, we can see it right here. Its equation would be y equals 4. Okay? Let's try another example. All right. Here, the order's been moved around a little bit, but let's not be deceived by this. I could rewrite this rational expression as y equals -4 times 1 over x minus 5 plus 2. Just rearranging my terms and factoring that rational term. Okay, so we can now see exactly what all our graph transformations are. We're going to start with y equals 1 over x. We know it's a rational function because x appears in a denominator. Then we're going to have a vertical stretch by a factor of 4. but that multiplier is a negative 4, so we're also going to get a reflection about the x-axis. And then lastly, we'll have our shifts. We're going to shift 5 units to the right and 2 units up. All right, so we have one extra step here. We've got that reflection. That's different from last time. So we'll go ahead and draw our graph here. I'll put in some scaling that I think is going to be pretty important down the road. Start off with our prototype here. Maybe I'll draw it in black. Now we get stretched vertically by a factor of 4, so all my points are going to get pulled away from the x-axis, or they're going to be have their y-coordinates multiplied by 4. So there's y equals 4 times 1 over x. And then we're going to have a reflection about the x-axis. So that piece in the top right quadrant is going to go down to the bottom right quadrant. And this piece in the bottom left quadrant is going to go up to the top left quadrant. So there's our reflection. And last thing we need to do is have our shifts. And again, this is going to move the asymptotes. Even for the green graph, the vertical asymptote is under the y-axis, the horizontal asymptote is under the x-axis. But these shifts are going to move them out. These rational graphs get a bit messy when we do them. But there's no avoiding it. So we've got, there's that top left branch of the green graph that's been shifted over and up. And this bottom branch of the green graph shifted over and up. Okay. And our new asymptotes, we've got a vertical asymptote at x equals 5, and we've got a horizontal asymptote at y equals 2. So you'll notice that all the graph transformation techniques, they work exactly the same. The only thing that's new is the prototype, and of course how the stretches and shifts affect the asymptotes is something a bit new, but that's just because asymptotes are new for this graph. We'll do some more complicated examples in class. Thank you very much.